Waidsum, once again you're welcome to Waidsum Academy. Today we have physics and our topic for today is electrical energy. Remember the previous class we did resistance. We've done resistance, we've done current, we've done voltage, which is potential difference. Today's we want to look at resistance and electrical energy. Now, since you've learned the Ohm's law, we say in Ohm's law, V is equal to I arrow. Remember that? We said in Ohm's law, V is equal to I arrow. We did that yesterday. Okay? So today, let's take a look at, let's start with that. We say V is equal to I arrow. V is the potential difference, or what you call the voltage, and I is the current, and arrow is the resistance. So we say V is equals to I arrow. This is Ohm's law, which we've looked at yesterday. We've applied it, and here we say you can make any of this the subject. We drew a triangle for this formula in our physics, in our previous physics class, and we said if you draw this triangle for this formula, and then hence we can probably have here V, the voltage, and here the current, B multiplied by the resistance here as a triangle. So we say if you have this triangle formula, you can easily and simply find any of the parameters. If you're looking for the voltage, you multiply the current multiplied by the resistance. If you're looking for the resistance, you say the voltage divided by the current. And if you're looking for the current, you say the voltage divided by the resistance. So we've itemized this, we've looked at this extensively. So what we want to look at today is the energy that is produced from this equation, the electrical energy equation. Now we say everyday application transfer electrical energy from the mains to other forms of energy in our appliances. The electrical energy from the mains, what do we mean by the mains? The mains is the energy coming from the, probably in the case of Malaysia, we say Tenaga Nasional, their source, their station, the power station. So the energy that is being transmitted from the power station is sent to our homes, our schools, our offices, our industries. Okay? So the main electricity is the one coming from the power station. When we say the mains, electricity from the mains, we're talking about the electricity coming from the power station. Okay? So this electricity that is coming from the power station is being transmitted and distributed to our homes. First transmitted and then stepped down with the use of step down transformer, and then after that the value step down continuously and constantly, and then this electricity is finally sent, 230 volts is finally sent to our homes. Now this 230 volts single phase voltage that is being sent to our homes is being supplied to various appliances in our home, like computers, like the television, the fans, the refrigerator, the gas cooker, whatever, no, not the gas cooker, the electric cooker, and so many things in our homes use electricity. Okay, if you look around, so many things in the home use electricity. Okay, now this electricity that is being used has a formula, or the energy that is being supplied to these appliances has a formula for calculation. For example, in a heater, like we use heater all the time to boil water in our home. Okay, so in a heater, this will transfer electrical energy to thermal energy. Remember, the electrical energy you supply to the heater, when you plug the heater to the electrical socket, when you plug the plug to the socket, the energy is being transferred in form of electricity, transferred into the heater. Now the heater will translate or transform this electrical energy into heat energy. If you transform this electrical energy to heat energy, that will heat the water and makes it hot. Okay. Now the amount of energy on the appliance transfer depends on how long the appliance is switched on for and the power of the appliance. So it depends on this factor, the power the appliance has, the heater has, and how long, the time. How long is the time? So energy is coming from two angles, the power and time it takes. for you to heat that material. The power is IV. Remember in one of our classes, we've itemized this. Power is IV. So we say the power and the time it takes. So energy is coming from power and time it takes. So we say 1 kilowatt iron uses the same amount of energy in 1 hour as 2 kilowatt iron used in 30 minutes, half an hour. So 2 kilowatt in half an hour, 1 kilowatt in 2 hours. So they're going to use the same amount of energy if you do the calculation. Okay. Now a 100 watt heater uses the same amount of energy in 30 hours as 3000 watt heater does in 1 hour. Yes, because when you do the multiplication, if you say 30 hours multiplied by 100, you get 3000. And if you say 3000 watt multiplied by 1 hour, you still get 3000 joules. So you get the same amount of energy in this regard. So hence, if that is the case, energy, I think in one of our videos we have explained energy formula. Hence, energy, electrical energy. When we say energy in this regard, we're talking about the electrical energy, okay, not the normal mechanical energy. So energy is given in this regard is given as the power multiplied by time. Power multiplied by time. Energy is power multiplied by time. Okay, electrical energy is the power multiplied by time. Now this power is P times time, which is T. Now power, electrical power is simply represented, so I use the symbol for energy. Energy E is equal to power. Now we're going to represent the power in electrical form. Okay, the power in electrical form. Power is what? Current times voltage. The current I multiplied by the voltage. Power is usually the current times voltage. Okay, current times voltage, that's power. Then multiply by time. This power multiplied by time gives us what we call the energy formula, electrical energy formula. So we need to take note all the time and every time that we're calculating energy in electricity, in electrical appliances, we use this formula. E is equal to IVT. We use E equal to IVT. So let's move on. So if we're given energy, E is the energy in joules. The unit of energy is in joules, right? The use of energy is in joules. And then the voltage is in volts. And the current is in ampere. Okay? And the time is in seconds. Is that okay? Now here is an example. Remember that 1 kilowatt, 1 kilo means 1000. When you say kilowatt, 1 kilowatt, you are saying 1000 watts. When you say 1 kilowatt is equal to 1000 watt. For example, if you say 1 kilowatt, 1 k-watt will be equal to 1000 watt. Any kilo, when you put the word kilo, is a prefix that is used with a unit. When you say 1 kilowatt, this is simply 1000 watt. Simply 1000. Kilo means 1000. Okay? Simply means 1000 watt of energy. Remember, power is unit is in watts. The unit of power is in watt. While the unit of energy is in joules. The unit of energy is in joules. Okay, now let's move up quickly and see what we can finish before the time finishes. Now, energy transfer in electrical circuit. So we see a circuit. The battery generates the energy that drives the charge around the circuit. This battery generates the energy that drives the charge. The charge, when it's moving, is no longer called a charge, it's called current. I've already explained that. The charge moves in a circuit, that charge becomes current. So when you see current, we're saying the charge that is moving. Okay, current means a charge that is moving. As it moves around the circuit, this is a bulb. Okay, when it gets here, energy is dissipated here. So meaning energy is lost here. So some energy is, form of energy is lost, it's dissipated. That's what makes the bulb to glow. The glowing you're seeing is some energy that has been dissipated on the bulb. Okay, and then some will be sent to this resistor. This is a resistor, meaning energy will be lost in this resistor. The remaining one will go back to the battery, and the battery energizes it and pushes the charge continuously. Okay, so this is what happens in a circuit. This is what happens in a circuit. Now the current transfers electrical energy from the power source and to the circuit components. What are the circuit components? The bulb and the resistor. The bulb and the resistors are circuit components. So the energy here is driven, or it drives the charge. The charge becomes the current. The current itself will now transfer the energy to this circuit component. The current transfer the energy to the circuit component. Okay, there are different domestic appliances, and each of them use different amount of energy. For remote control, they use little energy, not as great as other like heaters. Heaters use great amount of energy. So different home appliances use different amount of energy. Okay, most household appliances transfer energy from the AC main, electricity main that enters our house. Now, this can be kinetic energy or an electric motor. Motors are used in what? In vacuum cleaners. If you have vacuum cleaners at home, they use motor. In hair dryers, they use motor. In washing machines, they use motors. In refrigerator, they use motors. Okay? So motors are used in electrical motor. We studied motor and generators in the past before we did transformer. We've done electrical motor and we've done electrical generator. Okay? So motors, they convert electricity to motion. That's motor. Motor convert electricity to motion. They convert electrical energy to mechanical energy. They convert it to motion, like kinetic. Convert electrical energy to kinetic energy. That's motors. Like for example, your hair dryer, you plug it to the socket, and then you start producing that heat energy to dry your hair. And also the one way when you go to a restaurant or you go to toilet, you touch water, you put your hands under some hand dryers, they dry your. These are motors. They're using motor. The clipper for cutting your hair for the male they cut their hair, right? They cut their hair. So the clipper, they use motor. They use electric motor. They have motor inside them. It produces motion, and such you're able to cut your hair. You plug the clipper to electricity, and then produces motion. That electrical energy is converted to kinetic energy to produce motion, and that motion drives the cutting of the hair with the blades in front of it, helps to cut the hair. Similarly, washing machines, they have such same application. You put the motor drives, you plug the washing machine, electrical energy is driven to it, that electrical energy is converted to kinetic energy, that kinetic energy causes the spinning. The spinning is what washes the clothes and dries the clothes. Is that okay? So in case of washing machine. Refrigerator, same thing. Electrical energy, they have motors that produce, when it's plugged, then the electricity is converted to heat energy, and heat energy to, heat energy could be cold or hot, which is now used by the refrigerator. On heating devices, heating is used in what? Toasters. We have toasters to toast your bread. Okay, you have toasters in your homes to toast your bread, and this is electrical energy supplied to these toasters. Kettles to boil your water. Electrical energy supplied to the conductor, the metal, which becomes hot, and then it boils the water. And radiators, hot water is pumped from the boiler so that the radiator can heat up the room. Is that okay? So these are the applications. These are different applications of where we use electrical energy. Electrical energy, we cannot do without electrical energy. We cannot live today's world without electrical energy. The laptop, the computer we're using right now is using electrical energy. We plug it, we supply the electrical energy to power the computer. Other than that, the battery runs out, you don't plug it, and then the system will shut down. So electrical energy is very vital. Our phones, you plug it, you charge it, you supply electrical energy to it. All devices, they need electrical energy. Most of the devices, electronics, they need electrical energy. Without it, they will never be able to function. So electricity has become the bane of our life, has become the bane, the very core reasons for existence. Without electricity, you can no longer do much in today's world. You cannot achieve a lot in today's world. So that's why you see the third world nations that cannot stabilize electricity, they struggle, they suffer. They cannot develop. No one, no country, no nation can develop without electricity. Okay? No nation can develop without electricity. Nobody can get today's civilization without electricity and internet. You cannot have internet without electricity. So everything else comes after electrical energy. Everything else comes after electrical energy. In fact, electricity is life. Electricity is life. You don't have it, you don't have life yet. You're struggling. You're in the back of life. Okay, now let's quickly see what follows, what comes after that. Now let's take a look at electrical power. They go together. So electrical power. Okay, we do electrical power next time. I think our note is finished. We have to log in again in order to have access to this. So this is a short class. Thank you for joining us. Okay.